This video is just going to discuss, review some circle geometry and talk about what happens when we go around a circle, or how we calculate things around a circle. So the basics of circles, and I'm sure this is a review for everyone, is that halfway across the circle is the radius. Around the outside of the circle is called the circumference, which is equal to 2 pi r. Okay? And one of the angles is equal to degrees or radians. Okay, an entire circle is 360 degrees. We won't really be dealing with radians. Okay, now this line right here is actually a tangent line to the circle. So a tangent line is a line that just touches at one point the circle, and it's a straight line, and it tells you the slope of those positions. Okay, so a revolution is when you go a complete 360 degrees around. The frequency is how many revolutions you do in a second. Okay, so the revolutions in a certain time period. Okay. The period is the time that it takes to actually go around once. So period is a time measurement, and it's actually the inverse of the frequency. So the frequency is revolutions per second. The period is how much time it takes to revolve once, or rotate around the circle once. Okay, so frequency is the inverse of the period, or period is the inverse of the frequency. Okay. Now, at any one point, at any point tangent to the circle, that tells you the velocity at that specific point in the circle. Okay, and the tangential velocity can be taken by taking the radius over the period. Now, this is totally intuitive. You don't have to learn something new here. Remember that velocity is meters per second, or how far you travel over a certain time period. So 2 pi r is, the distance to go around the circle once, and t is the time to go around the circle once. Okay, so the circumference divided by the period gives you the tangential velocity. Okay, and since we see up here that frequency and period are inverse of one another, then we could also rewrite this and take what is 1 over t here and put in frequency, so 2 pi rf. Okay. Now this is called the angular velocity here, which is really just taking the angle and multiplying it by the radius, but we don't really have to worry about that. We won't use that very frequently. Alright, so let's just do a couple of examples. So let's say you have a record player, a turntable. Turntables are built to go at 2 different speeds, or RPMs, which means revolutions per minute. They spin at 33 1/3 and 45 most commonly. There's some other speeds too, but those are the most common record size. Okay, so this question asks you, the first one says, what is the period in seconds of a 33 RPM record player? Okay, so I'm going to go ahead and just show you how to do this. So you have 33.3 roughly, right? And sorry, I'm trying to do this with paint, so I'm really bad at it. Okay, so 33 1/3, and that's revolutions per minute. So if we divide it by 60, that will give us the revolutions every second. So let me just pull up the calculator here. So 33.3 divided by 60 gives me 0.55. Okay, so that's equal to, and this is 0.55, and that is revolutions in a second. Okay, now if you remember revolutions per second, remember that is how many revolutions you do in a time period. That is frequency. And frequency is equal to 1 over the period, or the period is equal to 1 over the frequency. So in order to calculate this, all we have to do is take the inverse of this number, which is just hitting this button. Okay, so I get that the time that it takes to go around a record one time is 1.8 seconds. The 33 1/3 revolution per minute is 1.8 seconds. Sorry, that's pretty sad. Okay? All right, so let's go back and just look at the other half of the question. Now it says, let's say you have a bug and it's sitting on the very outer edge of the 33 1/3 RPM record. Then what is its tangential velocity if the record has a radius of 0.15 meters? Okay, so let's just go back. I'm actually going to just erase all this. Oh, let me just open a new one. That's going to take too long. Okay, don't say that. Okay, so I'll just write, remember we've got t is equal to 1.8 seconds. Okay, so if you really think about it, like if you have a record like this, okay, every single point that you are on the record is going to take 1.8 seconds to go around, whether you're here or whether you're out here on the edge. Okay, because it's all moves as one piece. It takes 1.8 seconds to get around. The difference is that the further you are out, the farther you're traveling around the circle, and therefore your velocity is greater. Okay, so the radius, it tells us, is 0.15 meters. Okay, so it asks you velocity, and again, I just want to do this intuitively, not memorizing an equation. So if I want to go around this circle once, okay, that is the circumference, which is 2 pi r. Okay, so if I pull out my calculator, I just take, oh gosh, there's no pi on here, so I'll just do 2 times 3.14 times 0.15, and I get about 0.942. Okay, so to go around the outside of the circle is 0.942 meters. So that's how long, that's the distance the bug has traveled. And we know that the time it takes is 1.8 seconds. So velocity is just the circumference over the time, or how far you're traveling over the time. Let's pull that up. So take 0.942 and divide it by 1.8, and we get a velocity of 0.52 meters per second. That's the velocity the bug is traveling. We could also say that that is the tangential velocity, since that was the velocity on the very outside of the circle.